Welcome everybody, Math 104. We're working on section 1.3 today. This is applications of linear equations. So first one is the classic perimeter problem. And these problems are given the perimeter of a rectangle and the relationship between the length and the width. And from there we need to figure out what that length and width are. So in the first problem, length of a rectangle is 4 meters less than 3 times the width. So there's the relationship between the length and the width. We need to translate that into an equation. So here's the sentence. I took out the units because we don't need those. Length is 4 less than 3 times the width. So to translate this, first thing we're going to need to do is come up with some variables. Now the objective is to find the length and the width. Therefore those are unknowns. Unknowns are variables, so we need variables for length and width. So length, we use meaningful variables, don't just use x and y. That way, when you look at these equations, you know exactly what we're talking about. So L for length is always translated as the equal sign. Length is, so length equals. Now this part is 4 less than 3 times the width. So we got to multiply here. Times is multiplication, so 3 times the width. How do we write that? It's 3w. And now we know there's 4 less than that, so we need to subtract 4. So 3w minus 4. And all of the equations will be in this kind of format, where we've got one of the either length or width multiplied by something, and then we'll either add or subtract from it. So that's the equation we'll be using. And we're going to need one more equation, the perimeter equation. P equals 2L plus 2W. So 2 lengths and 2 widths. So all the way around the rectangle. All right, now we've got, well, I'm writing width here. We've got the width. And now we know the length. And instead of writing an L, let's just write in this expression, 3W plus 4. Or minus 4. Okay, so there's our rectangle. Now we're going to use both of these equations together. Because we can't solve either one of these. Because this equation has 2 variables, so we can't solve it. And this equation has 3 different variables, so we can't solve that one. But we do know some values we can plug in. So the perimeter is given to be 48. So I'm going to plug that in for P. So we got a 48 equals 2L plus 2W. And now we need to get rid of one of these variables. It's called substitution. So we have this expression for the length. So we're going to replace L with what it's equal to. So everywhere you see an L in the equation, just write in 3W minus 4 instead. So we got 48 equals 2 times, now put it in parentheses, 3W minus 4, because we have to multiply 2 by the entire quantity L. So that means we're going to need to distribute into the parentheses. And finish it off with 2W. So there's the same equation written with L substituted for. And now we've got one equation with only one variable, W. So now we can solve it. So that's what we're going to do. Start by distributing. 2 times 3W is 6W. 2 times negative 4 is negative 8. And 2W on the end. Now we can combine like terms, 6W and 2W. So it's 8W minus 8. Add 8 to both sides. Get 56 equals 8W. Divided by 8 on both sides. And W equals 7. All right, now we've got this equation all set up. So I can find the length by plugging in 7 for W. That gives us 17 for the length. Now we know the perimeter is 48, so let's do a quick check here. I'm going to plug in 17 for L and 7 for W. 2 times 17 is 34. 2 times 7 is 14. 34 plus 14 is 48, so that checks. So there's our length and width. Make sure you always check at the end of these. You should plug it back into one of the original equations to make sure it works out. All right, now use this procedure then for your turn number 1. For your turn number 1, we've got the length is 7 more than twice the width. So let's start by translating this. All right, we've got L for length is equals twice the width, that's 2 times the width, or 2W, and is 7 more than that. So add 7 on the end. L equals 2W plus 7. All right, now we're going to use the perimeter equation, and we're given that the perimeter is 74. All right, so we'll plug in 74 for the perimeter. Now again, we want to get rid of one of these variables, because we can't solve it with all these variables. So we're going to get rid of the L by substituting in 2W plus 7. So 2 times 2W plus 7. And then finish it off, plus 2W. All right, now we're down to one equation. We can solve this. So I'm going to distribute. Combine like terms. And we get rid of the 14 on each side. Gives us 60 equals 6W. Divide by 6, and we get W equals 10. All right, now we'll take that 10, plug it back into the perimeter equation. Oh no, we'll plug it into this equation, that'll be easier. So, L equals 2 times 10 plus 7. So L is 27. All right, let's see if that works. Now we'll plug both of these values back into the perimeter equation. 2 times L is 54. 2 times W is 20. 54 and 20 is 74. So that checks. All right, next type of problem we're going to look at is investment problems. So we're going to be given some information about 2 different investments, and we're going to figure out how much is invested into each account. So in the example, we got an investor putting $30,000 to work. Right, that's the total amount invested. And it's going to be split up into 2 accounts. $30,000, we're going to split that up into CD and an annuity. And the annuity pays 5%, and the CD pays 2%. And the 5% we should, when we include in the equations, we're going to write that as a decimal, so it'll be 0.05, and this will be 0.02. Now we're given the total annual income is $1,140. The simple interest equation is I equals PRT. Principal, that's the amount we invest. R is the rate as a decimal, and T is the amount of time. The T will be 1 for each, because we're investing these for 1 year each. All right, so we're going to need a couple of different equations to represent what's going on here. First of all, let's get some variables. The question asks for how much is invested in each account. Those are two unknowns, so we have to have a variable for each one of those. So I'm going to use meaningful variable names. For the CD, I'm going to use the variable C, and for the annuity, I'm going to use the variable A. Now we know that the amount of money put in those two accounts, if we add them together, is $30,000. So C plus A equals $30,000. So there's one equation we're going to use. And now what we can do is calculate the interest for each account separately. All right, so for the CD, the interest is going to be the principal, which is, we define that to be C, the amount of money we're putting into that account, times the interest rate, 0.02, times T, the amount of time, which is just 1. All right, so there's the interest for the CD account. And I'll do the same thing for the annuity account. And I'm just going to call these IC and IA just to make sure that's clear. Subscript means what we're talking about. Interest on the CD, interest on the annuity. You don't have to do that, I'm just used to doing things that way. So now we've got the amount we put in the account, which is A, times the rate, which is 0.05, times the time. So if we simplify this, we get 0.02C, and here we get 0.05A. So there's the amount of interest that we're making on each account. At the end of the year, that's how much you make. Now we're given in the problem the total annual income is $1,140. All right, this is the amount that we make off the CD. This is the amount that we make off the annuity. When we add them together, it gives us 1,140. So there's our other equation. 1140 equals 0.02C plus 0.05A. All right? Total interest equals the interest from the CD plus the interest from the annuity. All right, now we've got two equations, now we can solve them. So what I'm going to do is the same thing we did in the last problem is substitute. I'm going to get rid of one of these variables. So I'm going to solve this for A by subtracting C from both sides. So we get A equals 30,000 minus C. Now I'm going to take this and plug it in for A. Substitute. So 1140 equals 0.02C plus 0.05. Substituting for A, that's 30,000 minus C. And now we're down to one equation with only one unknown, and that we can solve. Now we're going to distribute 0.05 times 30,000, that's 1,500, minus 0.05C. Now we can combine like terms. 0.02C minus 0.05C. That's 0.03C. All right, now we can combine these two, subtract 1,500 from both sides. So that gives us negative 360 equals negative 0.03C. Divide both sides by negative 0.03. And we get $12,000. So $12,000 was invested in the CD. And now we can use this equation here to find A. So A equals 30,000 minus 12,000. So A equals 18,000. All right, now we should check to make sure this is right. So I'm going to take these two values and plug them back in here. So 0.02 times C, which is 12,000, that gives us $240. And then we'll take 18,000 times 0.05, and that gives us $900. Add those two together, and we get 1140. So that checks. And that brings us to your turn, number 2. We've got one account earning 6% interest, and then $5,000 less is put in the other account at 4% interest. Total interest is $3,000. How much is invested in each account? So we've got two accounts. Now the second amount is given in terms of the first amount. $5,000 less than the first investment. So we don't really need two variables. Let's use one variable for the first account. And we're going to define A to be the amount invested in the first account. All right, so A is going to be over here. And that's at 6%, so the interest. And again, it's just 1 year, so I'm just going to skip the 1. And we're going to go 0.06 A. 6% times the amount. I know over here, we're making 4%. But how much are we investing? We need an expression for $5,000 less than what's invested over here. We know what's invested over here is A. $5,000 less than that is A minus 5,000. So that means the interest over here is going to be A minus 5,000 times the interest rate, 0.04. And if we go ahead and distribute, that gives us 0.04A minus 200. All right, so here's the interest from the first account, here's the interest from the second account. If we add them together, we get 3,000. All right, so there's our equation with the two amounts of interest added in. Here's the total, here's the interest from the first account, and here is the interest from the second account. Add them together, we get 3,000. All right, combine like terms. 0.06 plus 0.04, that is 0.1A minus 200. Add 200 each side. All right, we got 3,200 equals 0.1A divided by 0.1. We get A equals $32,000. Now that we know A, we can find the amount in the second account. That's going to be A minus 5,000. And that's going to be 27,000. All right, so that gives us our two amounts. Now we should check. So we're going to take 0.06 times 32,000. That gives us $1,920. All right, and then our second amount is 27,000, so we'll take 27,000 multiplied by 0.04, and that gives us 1,080. Add them together, and we got 3,000. So that checks. Next type is a mixture problem. And we're going to use as an example a very common calculation in chemistry. So we've got 4 liters of a 15% acid solution. And we'll talk about what that means in a second. All right, so what does all this percent solution stuff mean? Well, let's say we've got a beaker here, and we want to make an acid solution. And you can have pure acid, which there's no water in it at all, or you can have an acid solution where you mix in some water. So let's say we've got 1 liter of acid, and that's all we have. That is a 100% 1 liter acid solution. 100% acid. Now let's mix in some water. I'm going to mix in 1 liter of water. So now I've got 2 liters of solution. Only 1 liter of it's acid. So this would be a 50% acid solution. Only 50% of the liquid is actually acid. The other 50% is water. And we could do 2 liters of water. In which case, we would take 1 divided by the total amount of liquid, which is 3, and that's 33%, rounded. So if we have 1 liter of acid and 2 liters of water, that would be a 33% acid solution. 1/3 of the total volume of liquid is acid. 2/3 of it's water. So that's how figure out how much, what the percentage is of an acid solution. Now for this problem, it's really helpful to use a table. And the table itself is going to reflect the equation that we use. The equation is amount of solution all right, so that's the total volume of both the water and the acid, total volume of the whole solution. Multiply that by the concentration. Concentration is this percentage value, and we're going to express that as a decimal, so we can do math with it. All right, but that is the percentage. So 33% in this case, 0.33 would be up in the equation. Here we'd have 0.4. And that equals the amount of pure acid. All right, so we take the total amount times the concentration is the amount of pure acid. So in this example, we've got 3 liters. If we multiply that by 0.33, we get 1. So we have 1 liter of pure acid. Now we're going to set up a table. All right, we've got the liters of solution, the amount of solution. That's going to be in one column. And then we got the percent as a decimal. And over here, the amount of pure acid in liters. All right, so the table follows the equation. So what we can do is take anything in this column, multiply it by something in this column in the same row, and that will equal what's in this column. Now let's fill in what we know. Now the way this table is set up is we've got this will be the 15% solution. And this is the 80% solution. And this is the mixture. All right, so this is what we're given, and this is what we want to make. So the way this table works is we're going to multiply across, just like the equation, to equal what's over here. And so one more thing we can do. When we go down, we're taking this solution, mixing it with this solution to get this solution. So we can add in this direction. The amount we have here plus the amount we have here is the amount we have in the mixture. All right, we're just pouring, let's visualize two beakers. We're just pouring them together. All right, so take this amount and this amount, add them together to get the total. Now let's fill in what we know. We are given 4 liters of the 15% acid solution. All right, here's the 15% row, 4 liters here. Now we know that's a 15% solution, so this is 0.15. And we know by the equation then that we can multiply straight across. And we'll do that in a second. Now, next part, the question asks, how much of the 80% solution do we need to add? So that's an unknown. We don't know it, so that's a variable. So we're just going to call that A for amount. We do know that it's an 80% solution, so this is 0.8. And now the mixture. The mixture we know is supposed to be a 40% solution. So 0.4 goes here. Now that is, let's see, that is all the stuff that we are given. And the rest we need to calculate. So we're going to multiply straight across. 4 times 0.15 is 0.6. Now I'll multiply straight across here. A times 0.08, or 0.8, so that is 0.8A. All right, now we don't have anything here, so we can't multiply across. So now we have to switch to adding. We're going to use the columns and add down. Now it makes sense to add here because we're talking about liters of solution, and it makes sense to add here because we're talking about liters of pure acid. We're just taking one beaker and pouring it in the other. But this one, these percentages, makes absolutely no sense to add those together because there's no addition relationship between these. All right. So here we're going to add these together to get A plus 4, and here we'll add these together to get. If you want to add and multiply. Actually, let's go ahead and multiply. Now that we have this, let's go ahead and multiply across, and then we'll add to get the final equation. All right. So we'll take this quantity times this. So 0.4 times A plus 4. All right, now our table is complete. We still need to solve for A. We need an equation to solve for A, so we use this column to solve for A. This plus this equals this. Right? The liters of pure acid in the first beaker plus the liters of pure acid in the second beaker gives us the total liters of pure acid. So that gives us 0.6 plus 0.8A equals 0.4 times A plus 4. And so there's the equation we need to solve. I'm going to distribute here. All right, now I'm going to get all the A's to the left, so subtract 0.4. And then we get all the numbers to the right, so minus 0.6. All right, so we get 0.4A equals 1, divide both sides by 0.4, and A equals 2.5. So that gives us 2.5 liters of the 80% solution. So we take that 4 liters of 15%, add 2.5 liters of 80%, we are going to get a solution that is 40% acid. And you should take that answer, plug it back into the original equation, check to make sure it works out. All right, your turn, number 3. A chemist would like to create a 25% acid solution. There's 6 liters of a 12% solution in stock. How many liters of a 60% solution must be added? So our goal is a 25% acid solution. There's 6 liters of 12% solution, so we got 12% here. And we're going to add in a 60% solution. All right, so I'm going to write in the decimals. We got 12%, that's 0.12. 60%, that's 0.6. 25%, 0.25. We're given that we have 6 liters of the 12%. All right, now we can multiply across. Gives us 0.72 there. All right, now we do not know how many liters of the 60% solution we need, so we'll call that A. Then multiplying across, A times 0.6, using our equation, we get 0.6A here. All right, now, a reminder, when we go down, we're adding, because we're combining these two to get our mixture. So that's A plus 6 here. And now we can multiply straight across again using the equation. So A plus 6 times 0.25. And now our table is complete. All right, now we're going to use this last column over here. We'll add together the amount of pure acid in the individual mixtures, or the individual solutions, to get the amount of pure acid in the mixture. So that is 0.72 plus 0.6A equals 0.25 times A plus 6. All right, now we'll distribute. I just got 0.25A plus 1.5. Can move the A's to the left and the numbers to the right. Alright, so that gives us 0.35A equals 0.78. Divide both sides by 0.35. And A equals 2.23 liters. So we're going to need 2.23 liters of the 60% solution. So we can do the check then. We know we have 0.72 liters of pure acid plus 0.6 times A, which is 2.23. And we'll see how much pure acid we get. Multiplying that out, we get approximately 2.06. And then we can take 2.23, plug it in here, and see if it equals. So 0.25 times 2.23 plus 6, and we get 2.06. So either way, we get 2.06 liters of pure acid. So that checks. All right, next up, we're going to look at a little different type of mixture problem. Not so much chemistry. If you had trouble with the last one, that's understandable. There's lots of new vocabulary and concepts in there. It can get a little confusing. Let's look at a little more common example of mixture. So we got a butcher, combines 90 pounds of hamburger, costs $1.50 per pound, with 50 pounds of ground sirloin that costs $3.60 per pound. Find the cost per pound of the entire mixture. All right, so the equation that governs this is amount equals times cost equals value. So the amount in pounds times the cost in dollars, whoops, cost in dollars equals the value, which is this is dollars per pound, and this one's in dollars. Okay, the amount in pounds times the cost in dollars per pound equals the value in dollars. Now we want a table. So we got hamburger, ground sirloin, and the mixture. All right, now we'll just make columns for everything in the equation here. Amount, cost per pound, and the value. Now let's fill in the values we know. We have 90 pounds of hamburger. So that's how much you put in there. And we know that that costs $1.50 per pound. So 1.50. Now we want to find the total value of 90 pounds of hamburger at $1.50 per pound. Multiply those together, we get $135. All right, next one, the ground sirloin. We have 50 pounds of ground sirloin, so put that in here. And the ground sirloin costs $3.60 per pound. Multiply those together, get $180 worth of ground sirloin. All right, now just like we saw with the chemistry example, we can add in this direction. We're taking this 90 pounds of hamburger, we're adding in 50 pounds of ground sirloin, total amount is then 140 pounds. And we can do the same thing with the value. Add these together, we'll find the total cost of the mixture is now $315. So what we need to know then is this, the cost per pound. And I'm going to use C as the cost per pound. All right, now we just use the equation then. So that means we can always multiply the amount times the cost per pound to get total amount there. So 140 times C equals 315. Solve for C, we're going to divide by 140, divide by 140, and C equals 2.25. So the cost of the mixture is $2.25 per pound. All right, last one, your turn, number 5, another mixture problem, a little different situation here. Talking about making an alloy. You got a gold alloy that costs 320 per ounce. It must be mixed with 100 ounces of an alloy that costs 100 per ounce. And we want the mixture to cost 160 per ounce. So we can use the same equation and same table. And instead of cost per pound, we got cost per ounce. Let's fill in what we know. The question asks for how many ounces of the premium alloy, the more expensive alloy, do we need? So that's our variable. So I'm going to use A for the amount there of the premium alloy. And the regular alloy, we're given that we have 100 ounces of that. And we're going to combine them. So A plus 100 is the amount of mixture. Now the cost per ounce, we got 320 for the premium alloy. And we've got 100 for the regular alloy, and the mixture, we want that to cost 160. So the value then, we're going to multiply across using the equation amount times the cost, dollars per ounce. So A times 320 is 320A. Now I got 100 times 100 here, that's 10,000. And here we can multiply across A plus 100 times 160. Now we can use this last column here to set up an equation. All right, the value of the premium alloy plus the value of the regular alloy equals the value of the mixture. I'm going to distribute. Okay, it's 168 plus 16,000. All right, now I'm going to get the A's to the left, get rid of these, subtract 160 from each side, 160A, and then add or subtract 10,000 from each side. So we get 160A equals 6,000, divide both sides by 160, and we get A equals 37.5. So that means we require 37.5 ounces of the premium alloy. So application problems like this can be pretty tough. So be patient with yourself and read through them real slowly. Make sure you understand every step. And if you have any questions, make sure you come see me. Have a great day.